All right, so this is a quite easy quiz, right? We've talked about which properties of vectors. We said, hey, I can represent all vectors using unit vectors along x, y, and z directions, which I called I, j, and k. What can I do with this I, j, and k? I can basically do all kinds of addition and subtraction, just treating I, j, and k as separate entities. All right? So let's do it. First of all, a vector is given here. Calculate a absolute value, so the length of a. How do I do this? Well, you can either remember that a magnitude is square root of ax squared plus ay squared plus az squared, or you could just as well remember that a magnitude is dot product of a with itself, well, square root of that. So a magnitude is square root of a dot a. How do I do a dot a? Let me just write it. 4i hat minus 3j hat plus 12k hat dot product 4i hat minus 3j hat plus 12k hat. The nice thing about dot product was, if I have two unit vectors in the same direction, their dot product is 1. If I have two unit vectors that are perpendicular to each other, their dot product is 0. So the only thing that's left here is I and I, j and j, k and k. All other products are 0. In the end, what I get is 4 square plus 3 square plus 12 square. I chose the numbers knowing full that while you were preparing for the university entrance exam, you had two you were fond of two right triangles. One of them is 3, 4, 5 triangle. So this is 5 square. And the other is 5, 12, 13 triangle, which is 13 square. So this is going to give me 13. If you don't remember 3, 4, 5, or 5, 12, 13 triangles, that's okay, because you can use calculators, right? Good. So part A is easy. How about part B? It's actually even easier, right? A plus B, when I have the expressions for I hat minus 3 j hat plus 12 k hat plus I hat plus j hat plus k hat. Well, I hat is multiplied by 1 here, 4 here, so this is going to give me 5 I hat minus 2 j hat plus 13 k hat. That's it. How about part C? Now I need a new vector C which satisfies the relation a minus b plus c is 0. Or vectors, I can do algebra with them. Now that I can actually add them, I can basically just say C is B minus A. So again, a straightforward way of writing things. Question? Comment? No? Okay, so B minus A, B is I hat plus j hat plus k hat, minus A is minus 4 I hat plus 3 j hat minus 12 k hat. All in all, this gives me minus 3 I hat plus 4 k hat plus 13, no, plus 4 j hat, and 1 minus 12 is minus 11 k hat. Okay, that's it. How about part D? The angle between A and B. This is A, I'm just making things up now. B, and the angle theta. How do I calculate the angle between any two vectors? We have defined two very useful products, but dot product is especially suited for calculation of angles. Why? Because if I calculate A dot B, I know that it's going to be A magnitude times B magnitude times cosine theta. Now A dot B I can also calculate by writing them in terms of components. What was A? It was 4I hat minus 3J hat plus 12K hat. Dot B is I hat plus J hat plus K hat. How about A magnitude? A magnitude I already calculated to be 13. B magnitude, let's quickly calculate B magnitude. B magnitude is square root of squares of the components. X component is 1, Y component is 1, Z component is 1. So it's going to be square root of 3. So this is going to be 3. So 3 times, let me write it like this, 13 times 3 times square root of 3. Excellent. Thank you. Now, let's do the dot product also by just looking at components. When I do the dot product, the only thing that survives is the dot product of the unit vectors in the same direction. So this is going to be 4 minus 3 plus 12 is 13 square root of 3 cosine theta. This is going to be 13 is 13 square root of cosine theta. So cosine theta is 1 over square root of 3, which means I can say the angle theta is arc cosine 1 over square root of 3. All right? If D is A cross B, calculate D. So D is A cross B, but what I need to calculate is the absolute value. That's what's asked. Now, if you want all the components of D, what do you need to do? You need to write this out as a 3 by 3 determinant, right? But does the question ask for all separate components of D? No, it doesn't. It actually asks for just the magnitude. And what was, we also had this geometric definition of cross product, right? So D absolute value was A absolute value, B absolute value times sine theta. Aha, great. A absolute value I already know, 13. B absolute value I already know, square root of 3. How about sine theta? If I know cosine theta, I also know that cosine square theta plus sine square theta is 1, or sine theta is 1 minus cosine square theta square root. So sine theta is square root of 1 minus 1 over 3, or square root of 2 over 3. Now I can plug this in here. It's going to be square root of 2 over 3. Square root of 3 is cancelled. Apparently the magnitude is 13 square root of 2. All right? Any questions? All right, good. Now we've done the hard thing. We've actually learned the math. Let's apply this mathematics to physics. Okay. Now, and it's going to be extremely simple. So how are we going to determine, or how are we going to define motion in 3 dimensions? Well, How did I define motion in 1D? Yes. Question.
We have another question.
Really, we did? Thank you. I completely forgot. Let me solve part F. That professor is giving questions with so many parts. It's, you know, like, it's inhuman. How do I find the angle between the B and the x-axis? Let's do it over here. Same idea, but how do I determine what actually defines the x-axis for me? I hat is the unit vector along x. So I can say B dot I is B magnitude times, what's I magnitude? 1 times cosine theta. B dot I, what's B dot I? It's just 1, right? I hat dot I hat is 1. I hat dot j hat and I hat dot k hat are 0. So this is 1. Excellent. So this is 1. B magnitude was 1 over square root of 3. So cosine theta is 1 over square root of 3. Let's call this another angle. So if this is B, this is I hat, this angle I'm going to call alpha. Apparently, alpha is 1 over, alpha is cosine inverse 1 over square root of 3 again. I like this angle very much for some reason. Any other questions, comments? No? Let me go back. Motion in 3 dimensions or 2 dimensions, in higher dimensions. What should I do? Well, how did I define motion in 1D? I defined 3 quantities, x of t, v of t, and a of t. I took derivatives to get from one to the other, and reverse path I did by integrals. That was in 1D. The only change I'll do in higher dimensions is to define my position, velocity, and acceleration as vectors. All right? That's the only change. So what I'll say is that now my position is a vector. Similarly, my velocity is a vector. My acceleration is going to be a vector. And very quickly, I can also remind you what speed was. Speed is going to be the length of the velocity vector. All right? How do I get from position to velocity or acceleration? Well, let me just take a derivative with respect to time. So I'm going to define my velocity vector as the time derivative of position vector. And at this point, usually a lot of students complain, hey, we've just learned about vectors, now you're taking derivatives of vectors. But there is really nothing to complain about, all right? Why? Because once I use my component notation, what I can say is that my position vector is actually made up of 3 components. Position along x as a function of time, position along y as a function of time, and position along z as a function of time will determine where my particle is at any given moment. So previously, I was just concerned about one of these quantities, x of t. Now I actually need to know x of t, y of t, and z of t for all times. That's what I would like to find out in my solutions. How do I get the velocity vector? I take the derivative of this expression. I hat, j hat, and k hat. They are vectors, but do they depend on time? No. Unit vectors do not depend on time. So they will just be like constants, right? So when I actually take a derivative, they will not matter, they will just go outside the derivative, right? So if, let's write this in its full detail, I'm taking the derivative of the position vector. So I hat is a constant, I only need to take the derivative of x component of position. Similarly for y, and similarly for z. I can even give names to these components. I'll call the derivative of x with respect to time as my x component of velocity. Vy will be my y component of velocity, and z will be my z component of velocity. Right? So that's what I mean by taking the derivative of a vector. What does it mean? It means I am just taking the derivatives of each component of the vector. Right? Good. Then similarly, I can define my acceleration. My acceleration is going to be the derivative of velocity. Now I know how to do it. So I can say my acceleration is acceleration along x, acceleration along y, and acceleration along z. And each of these accelerations, ax will be d by dt vx of t, or the second derivative of x of t. Similarly, ay will be d by dt vy of t. It gets really boring, so you should be thankful that we live in 3 dimensions, not in 10 or 26 dimensions. Now, so essentially, what am I saying? I'm saying all the formulas we have derived for one-dimensional motion are still valid, but I'm going to use them only for components. All right? That's all I'm saying. Let's solve one example of two-dimensional motion. All right? Let's actually investigate projectile motion. What I mean by this is, let me take a small mass and I will throw it with a speed of v0, making an angle theta with the horizontal. And what I would like to calculate is two things. I actually would like to calculate x of t and y of t as a function of time. So I'm putting my axes so that this is x and this is y. I also would like to find out what the curve is. So I actually want to see what y as a function of x is. And I'd like to find out how far away this small projectile lands. I'm going to calculate what the range is. Right? Now, how do I describe what actually is given here? The only thing that's given to me is that there is gravitational acceleration in this problem. So what is the acceleration vector? is there any component of acceleration in the x direction? No. So in the x direction, I don't have a, let me write it as 0 times I hat. So there is nothing in the x direction. How about in the y direction? Do I have acceleration in the y direction? Yes. What's its value? Minus g. Excellent. Minus g j hat. And there isn't even a k hat in this problem, so I'm not going to write it. Okay? Let's stick to two-dimensional vectors right now. Then, can you tell me what is the velocity of a particle with this acceleration? Well, technically, how do I go from acceleration to velocity? I need to integrate, right? But here, I have two components with very simple rules, very simple motion. If acceleration along x is 0, what kind of motion does this projectile do in the x direction? With constant velocity, motion with constant velocity. So whatever my initial velocity in x direction is, let me call this v0x, it's going to remain constant throughout the motion. So that's going to be v0x times I hat. How about the motion in the y direction? What kind of motion is that? It's motion with constant acceleration, right? So if I have constant acceleration, then my initial velocity in y direction will change in time as minus g times t. All right? So how about position vector now? Well, if I have constant velocity in x direction, well, I'll just have my initial position plus my constant velocity times t in the x direction. And motion with constant acceleration, we also know what the formulas look like. It's going to be y0 plus v0 yt minus 1/2 gt square in the y direction. What did the question ask me? X of t. Can I just read off x of t here? Yes. So this is x of t. Maybe let's remind ourselves that motion in I hat direction is with constant velocity, and let's talk about the second part, motion in j hat direction is motion with constant acceleration. But the question actually asked me to find two more things. How about finding the range? How do I find the range? Just a moment. Did I really answer my question? Did I reach my goal? I wanted to find x of t and y of t. I found x of t and y of t, but not in terms of given quantities yet. Why not? Because in the question I was supplied with the initial speed and the angle theta. And in the final expressions I have actually shown here, I have not expressed them in terms of the initial speed and theta. I must do that. And how do I do that? I need to think about the components. This is what I called v0x, and this is what I called v0y. So v0x is v0 cosine theta, v0y is v0 sine theta. Right? So before I get to range, I should write x of t is What's x0? Well, I did put my origin of coordinates to my initial point. So x0 is 0. v0x is v0 cosine theta t. And y of t is v0 sine theta t minus 1/2 g t square. Okay? How about finding the range? How far does this projectile land? I throw a stone with a given speed and angle. How far does it go? How do I find that? Well, I have two equations, x of t and y of t. I must find t, and that t would be the time of flight. How long would it take for this projectile to hit the floor again? So what's the equation that defines that time? Let's find time of flight, tf. Y of tf must be 0. Right? It must come back to the same level. So v0 sine theta t minus 1/2 gt square is 0. 1 power of t goes away. T is one solution of this equation because my y position was 0 at the start of the problem, right? So at t equals to 0, it was also 0. But now I can say 1/2 g t is v0 sine theta, and this is t flight, right? So t flight is v0 sine theta times 2 divided by g. Good. And what is range then? Range is how far I've traveled in the x direction during the same time. So it's going to be just x at time of flight, v0 cosine theta times time of flight. So if I actually write everything down, 2 v0 square sine theta cosine theta divided by g will be my range. Okay. I had one more question. I need to find y as a function of x. So if I'm not worried about where my particle is at a certain instant, but I'm just interested in the trajectory of the particle, not as a function of time, but y as a function of x. What's that? Well, this is actually quite easy to do. Let's rewrite our equations. X of t is v0 cosine theta t, and y of t is v0 sine theta t minus 1/2 gt square. So if I solve for t in the first equation, so I can write this as t is x divided by v0 cosine theta, and just use it in the second equation, y as a function of x then will be v0 sine theta x divided by v0 cosine theta minus 1/2 g x square v0 square cosine square theta. Right? V0's cancelled here. Y of x is x times tangent theta minus 1/2 g over v0 square x square divided by cosine square theta. So it's a parabola. Okay? Does the answer make sense? Let's think about it. Y as a function of x. Now, what does the trajectory look like if g was 0? If I was in free space and I threw an object with v0 making an angle theta, what kind of motion will it have in outer space, let's say? It will just go like a straight line. So when g is equal to 0, think of g being 0 here. That's exactly what I find. Y would be just my straight line when g is 0. What's the action of g? What's the action of gravitational pull or gravitational acceleration here? It's going to bend my curve into a parabola. As you go farther, you'll actually go also down because you're accelerating. So that will be my full curve. Okay. The action of g you can see from the second term. All right. Let me solve one more quick question. For a given speed, v0, which angle gives the maximum range? I know that most of you have this memorized as 45 degrees. Nonetheless, let's find it out. How do I solve questions like this? When I hear the word maximum, what should be the first thought in my mind? Maximum means its change, rate of change is 0. So it's the peak point. At peak points, rate of change is 0, which means the derivative of that is 0. So essentially, what do I mean? I've already found the range. Range was 2 times v0 square sine theta cosine theta divided by g. So now range is a function of theta if v0 is fixed. This question, maximum, means if I take a derivative of range with respect to theta, I should equate it to 0. That is how I find maxima and minima. I take a derivative of the function and equate it to 0. Okay? Let's take the derivative. dr dt. Now, v0 squared, 2 and g are constants. Sine theta, cosine theta. Do you remember how we take the derivative of a multiplication? Yes. This is going to be cosine theta times d by d theta sine theta plus sine theta times d by d theta cosine theta. So this is going to be 2 v0 square over g. What's the derivative of sine theta? Cosine theta. What's the derivative of cosine theta? Minus sine theta. Or cosine square theta minus sine square theta is equal to what? It's equal to 0. Or in other words, cosine square theta is equal to sine square theta. For which angle is cosine square equal to sine square? The only solution is when theta is 45 degrees, or we express angles in radians, pi over 4. We could have saved a lot of trouble to ourselves by recognizing that this is actually v0 square over g sine 2 theta. Okay? That would have been easier. Nonetheless, that's going to be my answer. And next time when we meet, I'll actually ask you to solve another question. I'll ask you the following. Let's say that I am a distance L from a wall, a vertical wall. And I will throw my I'll throw a small stone with speed v0. The question is, what is the maximum height I can reach by throwing a stone with speed v0 if I am a distance L from a vertical wall? Okay? So that will be our next quiz. I'm giving you spoilers.